Hi folks, we're going to take a brief look here at two of the constructivist-based instructional models that you're going to be looking at, problem-based learning and project-based learning. Both of these instructional models are grounded firmly in Piagetian ideas about learning and offer many opportunities for the kind of trial and error learning that Piaget believed helps people to accommodate schemas, to change what they believe, to build new schemas, and to be the kind of creative, inventive people that he believed education was intended to produce. First of all, I want to introduce a term that is often associated with both of these, constructionism as opposed to constructivism. You will hear that term, constructionism, often, and basically constructionism is simply constructivist theory, learning theory, put into action in the classroom. Okay, the term was originated by someone named Seymour Papert. Here's a picture of him looking like everybody's idea of a college professor. He wrote a very influential book in 1980 called Mindstorms: Children, Computers, and Powerful Ideas. And way back then, he was looking at how computers, desktop computers, which were at that time a brand new technology, could be used to help children do meaningful learning in a constructivist way, and he named that constructionism. And if you have not read that book, it is one of the seminal books in education, especially in terms of technology integrated education, and it's definitely worth reading. A lot of really original ideas in there. Anyway, one of the reasons we're looking at these two together is because they have a lot of resemblances, and often people are a little confused. People will write about problem-based learning, project-based learning. What's the difference? And the answer is, in many ways, they are similar. There is one fundamental difference. Okay, let's take a look at problem-based learning. Problem-based learning starts with a problem. The goal is to solve the problem. And I just wanted to give you an idea of the breadth of types of problems you could be looking at. You can be looking at problems that are essentially physical or essentially mental or kind of mixed. You can be looking at problems that are actual real-life problems. And so, like a physical real-life problem is figuring out how to pack a box so that something doesn't get broken. A physical simulated problem, though, is something like Angry Birds game. You're simulating shooting things, targets, but you're not actually shooting. Or problems are often in problem-based learning completely manufactured. One of the most famous ones down here is the two-string problem, where you hang two strings from the ceiling and somebody's in the room, they're given some tools and everything, and their job is to figure out how to grab both strings. Okay? A purely physical problem. Now, by purely physical, I don't mean you're not using your mind to solve it. Obviously, you are. But what I mean is the context of the problem is physical. Okay, in mental problems, a real-life problem you might pose to someone for learning is getting a candidate elected, a real candidate, maybe in a school election, maybe going out and working for a real candidate, or making a real budget. Okay, you can also do those two things as simulations. You can simulate an election, you can simulate a budget. Mock trial is a very well-known mental problem simulation. The poverty game is another one. And again, these things don't even have to have anything to do with real life. Most card games are manufactured mental problem-solving exercises. And then, of course, lots of things are not just physical or mental, they're mixed. So in real life, if you pose the problem of reducing air pollution, you have some physical elements involved and you have some mental ones. Running a food pantry, same thing. You've got to ship the food, you've got to figure out how to collect it, lift it, deliver it, but it's also a mental problem. How do you persuade people to donate food? How do you decide which recipients should get it? Simulated problems like case studies and vignettes are very, very common. in problem-based learning. They're based on real-life ideas, but they aren't real people that you're looking at. And of course, you also get purely manufactured problems that are mixed, like the famous Tower of Hanoi problem that you see here. Project-based learning starts with a product or an artifact. The goal is to produce the product or artifact. So it starts with the requirement for a product or artifact. So that is the essential difference between the two. Problem-based learning starts with a problem that needs solving. Now you might end up producing a product to solve that problem, but your main goal is solving the problem. Whereas project-based learning starts with a requirement to produce a product or an artifact, and your main goal is to do that. Now you're obviously going to have to solve a lot of problems to do that, but your main goal, your endpoint, is the product. So you can see how these things are very closely related. The product, by way, in project-based learning can be a product like a lesson plan. It doesn't have to be a material product, just like the one you're doing, actually, for this class. That's project-based learning you're doing, essentially. It can also be a physical product, like building a cabinet. It can also be a purely artificial, constructed kind of a product, the famous marshmallow challenge, in which you are given 20 pieces of spaghetti and a yard of tape and a yard of string and one marshmallow, and you have to build the highest structure possible, and the marshmallow has to be on the top. That's a totally man-made, artificial, project-based exercise. Now, are you going to have to solve some problems to do that? Yes, you are. But the object of the game there is to produce that artifact, the tallest tower possible. But really, what's more interesting about both of these is not how they're different, but how they're the same. They both, when done well, involve complex questions and issues. It is not problem-based learning to give a kid a sheet of multiplication problems, okay? It is not project-based learning to ask children to produce one slide summarizing the chapter. That's not a project, okay? It's got to be complex. It's got to have multi-facets. Ideally, it has some kind of authentic purpose. And remember, an authentic purpose, I mean, back there on the marshmallow thing, if those people take that on as a challenge and they're going to show it to other people and it's an exciting contest, a contest is an authentic purpose, just like a football game is an authentic game, okay? But honestly, these things are done best when they serve some kind of real-life performance or other kind of real purpose. You have to draw on multiple sources of knowledge to do both of these things. To solve your air pollution problem, you have to figure out and draw knowledge from a multitude of places. The same thing with the marshmallow problem challenge. You have to draw on your knowledge of physics. You have to draw on your knowledge of construction. You have to draw from multiple people in the group. Also, there are almost always in these multiple potential correct answers. It isn't problem-based learning if there's only one answer. It's not project-based learning if all the projects have to look the same. So when, the elementary school teacher gives kids exact instructions for how to make snowmen out of paper plates and cotton, that's not really project-based learning, because all the snowmen are going to come out the same. Now, if she'd handed them the plates and the cotton and the glue and a bunch of markers and said, make something that symbolizes winter for you, or that has to do with winter if you're talking to kindergartners, then that's a lot more like a project-based learning, because you could get lots of different answers. And usually they do not have to be. Both projects and problems can be done individually, but usually they involve collaboration. So that's about project and problem-based learning.